And photons are the quantum state, or the quantum nature of light, which light has wave particle duality. Matter also has wave particle duality. So another thing too, after you kind of absorb food particles love interacting with photons. Food particles love interacting with photons. Well, yes, food is made of ordinary matter, baryons, and that does interact with photons. Yes, that's correct, Ver. I think you got it. You got it. So after you kind of digest what I just said about the mass charge spin state, quantum states of all these different particles. So I was giving you examples of electron, muon, tau, but remember that it's also possible for the quarks, the entire quark family, and it's also possible, of course, for the bosons. I keep mentioning photon as an example for boson because everybody knows the photon. It's just light. So I keep mentioning that one. But there are actually other bosons as well. Some other examples of bosons are W and Z bosons. Now, these are the carriers of the weak force. So if you've heard of the weak force, it's one of the fundamental forces. It's different. It's not the same as the electromagnetic force. It's not the gravitation force. It's not the strong force. It's another whole thing. And the carriers of that thing is the W and Z bosons. So the bosons we find are often the carriers of these interactions, and basically the particles are exchanging that boson in order to interact with each other. So oftentimes you'll see that photon is, of course, involved in interactions with things like electron, proton, all of that. And then when it comes to the neutrinos, which is a type of lepton, neutrinos are in the same particle family as electrons. When it comes to neutrinos, they don't interact with photons. So somebody just mentioned WIMPs. That's good. Weakly interactive massive particle. So somebody just mentioned, where is that comment? Thank you for 20 likes. Can we get 30 likes? Oindri Zakami. The stream is way too educational. Okay. Strongly interactive. Strongly interactive ones are called simps. So, you mentioned, Reese, I think, mentioned WIMPs, weakly interacting massive particles. WIMPs are actually a candidate for dark matter. But it's good that you bring this up as we talk about particles, and I think I was just now mentioning neutrinos. The stream is good. She makes it food. Yes, if you think of all of this as food, then I think we're all good. So weakly interacting massive particle is a candidate for dark matter. Why am I saying candidate? Because dark matter is not confirmed. We don't know confirmed like what dark matter is, but we can imagine and think things and hypothesize and try to find such a candidate that we have thought up with various experiments and things like that. WIMP is one of them. So weakly interacting massive particle. Now, the first candidate that people thought of when it came to dark matter was actually neutrinos. So this neutrino particle that I just mentioned is, yes, neutrino is a candidate. Neutrino was a candidate for dark matter as well. Why? Because neutrinos are very, very elusive. So I was just now mentioning certain boson examples, W and Z bosons. Those are the carriers of the weak force. Turns out that neutrinos are particles, they are types of leptons that only interact through the weak